Okay, so welcome to all of you. In the last lecture or in the last video, we have seen some problems on the Langrages multiplier. Okay, so same thing we are doing here. So use the Langrages multipliers. Use the Langrages multipliers to find the maximum and minimum value of the function f of x y z is equal to x square plus y square plus z square, subject to the constraint x plus y plus z is equal to 12. Okay, so solution, given that f of x y z is equal to x square plus y square plus z square, g of x y z is equal to x plus y plus z is equal to 12. Okay, so fx is equal to lambda gx, implies that twice x is equal to lambda. Okay, so fy is equal to lambda gy. Fy is what? Twice y is equal to lambda. We call this as 1. We call this as 2. Okay, so fz is equal to lambda dz. This implies that twice z is equal to lambda. We call 3. Okay, so now your x plus y plus z is equal to 12 now. We call this as 4. Okay, so one implies that x is equal to lambda upon 2. 2 implies that y is equal to lambda upon 2. And 3 implies that z is equal to lambda upon 2. Okay, now 4 implies that. I'll put the value of x, y, z. Okay, so this is what then lambda by 2 plus lambda by 2 plus lambda by 2 is equal to 12. So this is what 3 lambda by 2 is equal to 12. So lambda is equal to, so this is 4, so lambda is equal to 8 now. Lambda is equal to 8. So therefore x is equal to y is equal to z, because what here x, y, z are lambda by 2. So this is 4. This is what? 4. So therefore so 4, 4, 4 is a critical point. Okay, so f of 4, 4, 4, f of 4, 4 is what? 16 plus 16 plus 16 is equal to 48. Okay, so now here we cannot conclude that the function has minimum value or maximum value. Okay, so for that we'll find fxx and fyy. Okay, so now see here fxx is equal to 2, fyy is also 2, and fxy is 0 now. Fxy 0. Your delta is what? So delta is AB minus c square. So this is 4 minus 0. So this is 4. This is 0. Right? So your A is what? 2. Your A is 2. Is greater than 0. Right? So therefore, so for at 4, 4, 4 now, at 4, 4 this condition there, your delta is greater than 0 and your A is positive. That means what? F has minimum value. This is minimum value at 4, 4, 4, 4, 4, 4. Right? And so this is the minimum value. Therefore, minimum value of F is 48. Minimum value of this is 48. Okay, so I have proved that the minimum value, this is the minimum value. Now see here, you can check here what, if you increase your x, then your function is also increasing, right? So if you increase your y also, the function is also increasing. If you increase the value of z, so if x, y, z are increasing, the value of f of x, y, z is also increasing. So that means what, this is what 4, 4, 4 will be the minimum value of this one. Okay. Now we'll take the next problem. So without finding that ABC also, you can conclude that whenever your x, y, z are increases, then your function is also increases. Therefore, f of 4 is the minimum value. Okay. So from that also you can conclude that. Okay. So no need to find actually the values of A, B, C, delta, and so on. Okay. Now we will take the next problem. Use Lagrange's multipliers to find maximum minimum value of the function f of x y z is equal to x y z, subject to the constraint x square plus 2y square plus 3z square is equal to 6. Okay. Solution. Given that f of x y z g of x y z, so this is what x square plus 2y square plus 3z square is equal to 6. Okay. So fx is equal to lambda gx, imply that fx, this is what yz is equal to lambda into twice x. I call this as 1. Okay. So fy is equal to lambda gy, this implies that xz is equal to lambda into 4y. I call this as 2 now. Okay. So fz is equal to lambda gz, this implies that xy is equal to lambda 6z. I call this as 3. And this is what x square plus 2y square plus 3z square is equal to 6. I call this as 4. So what I do, I multiply by x here, y here, and z here. Okay. So x into 1 plus y into 2 z into 3 gives. What I do, I take a multiplication x y z x y z x y z. So we get 3xyz here. 3xyz, because we are multiplying by x, this is xyz. We are multiplying by y, xyz. We are multiplying by z here, xyz. So all the three terms are same, and we are taking the addition of this one. So we take the addition of the LHS, that is what your xyz. Now here what, lambda is common now. Lambda is common. Okay, so what is here then? This is what, twice x square. This is 4y square. So this is what, twice x square plus 4y square plus 6z square. Okay, so this is what, 3xyz is equal to lambda into lambda. So I can take 2 common now here. I take common. So what we get then, x square plus twice y square plus 3z square. So x square plus twice y square plus 3z square is 6. So that is what, 3xyz is equal to 12 lambda. So lambda is equal to what then, xyz upon 4. Lambda is equal to xyz upon 4. So I will put that lambda in the equation 1 now. So 1 implies what, yz is equal to twice x into xyz upon 4. Okay, so I cancel that y and z. So what happened in here? So this implies that I cancel that y here. Okay, so this implies that, because what, y, if x is equal to 0, y is equal to 0, then function is 0, right? So I will not take the value of x is 0, y is equal to 0, z is equal to 0, because from that we get the value of the function is 0 now here. So I will cancel that yz. So what I get then, this is what, x square is equal to 2 now. X square is equal to 2. How? So this 2 get cancelled, this is 2, x into x is x square. I will shift that to this side. So this implies that x is equal to plus or minus 2 now. Okay, so 2 implies now 2. I will put the value of 2. Xz is equal to 4y into what, xyz upon 4. So this implies I can cancel this xz, so I get y square is equal to 1. I get y square is equal to 1. So this implies that y is equal to plus or minus 1. Y is equal to plus or minus 1. Again, I put 3 implies. So this is what xy implies xy. Xy is equal to 6z xyz upon 4. This implies that. Now see, your xy get cancelled. So this is what, so z square is equal to. Now see here what, 3 and this is 4 now, 6 by 4. So this is 3 by 2. So this is 2 by 3. Then z is equal to plus or minus root of 2 by 3. Root of 2 by 3. So what we get? The value of x is what? X is equal to plus or minus 2. Y is equal to plus or minus 1. And z is equal to plus or minus root 2 by 3. Plus or minus 2 by 3. So we find the value of this one. Find the value of this one. So what is f of x, y, z? So f of x is what? Plus or minus 2. Plus or minus 1. Plus or minus root 2 by 3. Root 2 by 3. Or root 2 by root 3. E is equal to. What is that? This is the product. What is the product of this one? Okay. So there may be what? Here what? Actually these are the how many points here? So see, this is 2, 1, root 2. Okay. 2, 1 minus root 2. 2 minus 1 minus 2 minus 1 root 2. Then 2 minus 1 minus root 3. So from 2 you have the 4 points. From 2 and 4 points. Again what we will do? We will take the plus 1 and we will change the value of this one. Right? We will change. That means there are what? How many points are there? There are 12 points. These are the 12 points. So if you take the product of this one, so what happens? We will take the product. So either what we will get, this is the plus sign or minus sign. Right? Whatever the sign may be, we get two values in plus or minus form. Take the product now. This is what? 2 root 2 upon 3. 2 root 2 upon 3. So now what is the value of x now? So x square, see the value of x square. So value of x square is equal to 2. So x is plus or minus root 2 actually. X is equal to plus or minus root 2. So that means what here? 2 by plus or minus 2 by root 3. 2 by root 3. Right? So what is the maximum? Then maximum of f is what? 2 by root 3. And what is minimum? Minimum of f is minus 2 by root 3. Okay. So we get x square is equal to 2. That means x is equal to plus or minus root 2. Okay. So just correct that. Okay. So the problem is over now. We get a maximum value and we get a minimum value. No need to find a separate. No need to separate all the things because there is a product. So if this is separate, this is plus x plus y plus z, then we have to do this one, right? So you have to separately, you have to find a value of this one. But there is a product, so no need to separate all the 12 points. Okay, so take the next problem. Use the Langrages multiplier to find maximum and minimum value of the function f of x, y, z is equal to twice x plus twice y plus z. Twice x plus twice y plus z, subject to the constraint x square plus y square plus z square is equal to 9. X square plus y square plus z square is equal to 9. Okay, so we'll solve this. Okay, solution. Given that f of x, y, z is equal to twice x plus twice y plus z, and g of x, y, z is equal to x square plus y square plus z square is equal to 9. Okay, so fx is equal to lambda gx. Fx is equal to lambda gx. This implies that what is your fx is 2. Lambda, this is twice x. Fy is equal to lambda gy. This implies that 2 lambda twice y. Fz is equal to lambda gz. I call this as, okay, we will give a number later on. Okay, so 1 is equal to lambda into twice z. We call this as 1, call this as 2, call this as 3, and your x square plus y square plus z square is equal to 9. Call this as 4 now. Okay. So now see from one implies lambda is equal to, so lambda is equal to, instead of lambda, so we find the value of x now, instead of finding the lambda. So x is what? 1 by lambda. X is equal to 1 by lambda. So we put 2 implies that y is equal to, again y is equal to 1 upon lambda, and 3 implies that z is equal to, 1 upon 2 lambda. Z is equal to 1 upon 2 lambda. 1 upon 2 lambda. So we have the equation 4, right? Without using the equation 4, don't find the values of x, y, z. Okay. So 4 implies what? So take the square of this one. 1 upon lambda square plus 1 upon lambda square 1 upon 4 lambda square is equal to what? Is equal to 9. Is equal to 9. So this is what? 4 plus 1 upon 4 lambda square is equal to 9. Right? So 4, so this is what? Lambda square is equal to, I will shift the lambda square to that side. I have to take the 4 as it is here only. So 9 get cancelled. This is 4 plus 1, 9. 9 upon 4 lambda square is equal to 9. So 9 get cancelled. So 1 upon 4 lambda square is equal to what? Is equal to 1. So I will only shift the lambda square to that side. Instead of writing that side, I will write this side. Okay. So lambda is equal to, this implies that lambda is equal to plus or minus 1/2. So lambda is equal to plus or minus 1/2. So what happened in x? So x is equal to 1 upon lambda. So plus or minus 2. Y is equal to 1 upon lambda with plus or minus 2. Z is equal to 2 lambda. Okay. So plus or minus 1 now. Plus or minus 1. So that means what here? So actually, so we cannot write this in the form plus or minus 1. We write this what? If lambda is equal to 1/2, then x is equal to, lambda is equal to 1/2, then x is equal to 2, y is equal to 2, z is equal to 1. Okay. So if lambda is equal to minus 1/2, then x is equal to minus 2, y is equal to minus 2, z is equal to minus 1. Okay. So now we will find the value of f of 2 to 1. F of 2 to 1 is what? 4 plus 1 is 8 now. Now f of what? Minus 2 minus 1 is minus 4 minus 1 is equal to minus 8. Oh, not minus 8, actually 9. This is 9. Okay. This is what? 9. Minus 9. Okay. So therefore, which one is maximum? Maximum is plus 9 and minimum is this. So maximum value of f is equal to 9 and minimum value of f is equal to minus 9. Okay. So very simple problem. Okay. So we take one more problem. Find the maximum minimum. Okay. So not here maximum minimum. Here not given. So now we are free to apply. Now in this problem we are free to apply any method now. Okay. Here the command is not given. So okay, command is given. Use Langrages, multipliers to find three positive numbers whose sum is 48 and the product is as large as possible. Okay. Now here what? This is given now. Then if this is not given, then you are applied to you are free to apply any method now. But here the Lagrange's method is given to you. You need the f of x y and you need the q of x y z. Okay. Okay. So what do I have to do? We have to find three positive numbers. Three positive numbers. Okay. So we write the solution. Let x y z be three positive numbers such that what their sum is 48, such that x plus y plus z is equal to 48, and the product is maximum. That means we have to maximize the product. Okay. So f of x y z is what the product is, what x y z. Okay. So therefore what g of x y z is what x plus y plus z is equal to 48, right? So we write this what fx is equal to lambda gx. What is your fx then? Yz. Fx is yz. Lambda. Okay. So this is lambda. Fy is equal to lambda dy. So this is what xz is equal to, again this is lambda. Fz is equal to lambda gz. So this is what xy. This implies that. This is also same as lambda. Okay. So that means I multiply. This is 1. This is 2. This is 3. This is 3. And x plus y plus z is equal to 48. This is your 4. Okay. So what do I do? X into 1 plus y into 2 plus z into 3 gives. Okay. So I multiply by x here. So this will be xyz. This will be xyz. This will be xyz. So this is xyz. Now lambda will be common because here lambda is 2, right? So I multiply by x here, multiply by y here, multiply z. So this is x plus y plus z. Right? But x plus y plus z is 48. So that means what? xyz is equal to lambda into 48. So lambda is equal to xyz upon 48. Okay. So I put lambda is equal to xyz in 1. So 1 implies that. So if you put, I put here lambda as xyz, your yz get cancelled because xyz are the positive numbers, they are not equal to 0. So yz get cancelled. So this is what then. Lambda is equal to xyz. So x is equal to 48. X is equal to 48. Oh, this is 3xyz. This is what xyz, 3xyz. So this is 3xyz, right? So 3xyz means what? This is 3. So this is what? xyz upon 16 now. xyz upon 16, right? So what we get then here? So 1 implies that x is equal to 16 now, right? You understand this? This is what? Lambda is equal to xyz upon 16. Yz get cancelled. We get what? 1 is equal to 1 now. X upon 16. So x is 16. So similarly, 2 is also same as y upon y is equal to 16 because they are the same now. So 3 also implies that z is equal to 16, right? So therefore the required numbers are 16, 16, 16, right? So therefore the required positive number, therefore the required positive numbers are 16, 16, 16, right? These are the only, right? So now see, if you take the value of this, what suppose this is 4, this is 4, this is 12, is 28, 16. This is also a pair. This is also a triplet whose sum is 48. Now say, see the product there. This product is not maximum now. This product will be the maximum, right? This product will be the maximum, right? So you check that. You take any triplet such way that your sum is 48 and see the product. The product is always minimum of this what? This is 16 cube now. Product is minimum less than 16 cube. So you take any triplet now. So this is a powerful method. Lagrange's multiplier method is powerful method. Okay. Now we'll take the last problem of this chapter also. Use Lagrange's multipliers multiplier to find the point on the plane x minus twice y plus 3z is equal to 6, that is closest to that is closest to 0 1 1. Okay, so what we'll do, we'll take a point on the plane. Okay, so let I take pxyz be the point on the plane x minus twice y plus 3z is equal to 6, which is closest to I will give the name 0 1 1. Okay, so therefore d is equal to, I take a distance, that is what pa, this will what root of x minus 0 square y minus 1 square z minus 1 square, right? I have to minimize this. I want to shorter distance from this, right? So I have to minimize this. So I will write this is what I will to minimize the root. I is nothing but to minimize the square also, right? So I will take this is what x y z, and I will take the square of that one. So this is what x square y minus 1 square z minus 1. So z minus 1 square, z minus 1 square. Okay, so g of x y z, g of x y z is what here? Here that is the plane. That is what x minus twice y plus 3z is equal to 6. Okay, so this is what then fx is equal to lambda gx. So your fx is what? Twice x. This implies that twice x is equal to lambda into 1. Okay, I call this as 1. Fy is equal to lambda gy. What does this imply? Fy 2 into y minus 1 into derivative of y minus 1 is 1. So lambda is equal to minus 2, lambda minus 2 now. So derivative of this is minus 2. Okay. So fz is equal to lambda gz implies that fz. So this is fz. So this is what 2 into z minus 1 into derivative of z minus 1 is 1. So this is equal to lambda into 3 now. Lambda. I call this as 2. I call this as 3. And this will be your 4 now. X minus twice y plus 3z is equal to 6. This is 4. With the help of this 1, 2, 3, 4, we have to find the value of this. Okay. So what we will do now here, I can find the value of x from here. I can find the value of y from here. I can find the value of z from here. So x, y, z. I get the value of x, y, z in terms of lambda. I put here. I get the value of lambda. Again, I will get the value of this. Okay. So 1 implies that. 1 implies. So I will find the value of x here. So x is equal to lambda by 2. X is equal to lambda by 2. 2 implies that. What here? 2 get cancelled now here. 2 get cancelled. So y is equal to 1 minus lambda. This is lambda now. So your 1 is shifted to that side. Again, this is z minus 1. That means z is equal to. So z is equal to. This is what? 3 by 2. Okay. So 3 lambda by 2 plus 1. 3 lambda by 2 plus 1. Okay. So 4 implies that. This is 3 implies that. Now 4 implies that. You have the value of x, y, z. We put the value of x, y, z here. Then we get the value of lambda now. So lambda by 2 minus 2 into 1 minus lambda 1 plus 3 into 3 lambda by 2 plus 1 is equal to 6. Is equal to 6. Is equal to 6. Okay. So I multiply by 2 first. I multiply by 2 first. So what happens is this is what lambda minus 4 into 1 minus lambda plus I multiply by 2, I multiply by 2 inside. This is 3 lambda plus 2 is equal to 6. Okay. So see here, I have multiplied by 2 inside the bracket. I'll open the bracket now here and I'll correct the value of lambda now. Lambda, this is minus 4 lambda become plus 4 lambda. So this is 5 lambda plus 9 lambda, so 14 lambda. So this is what? 14 lambda. So 14 lambda, 14 lambda. Okay. Now check the constant. So this is minus 4. Your constant is what here? Minus 4. And this is what? Plus 6. And plus 6 is there, right? So 6 get cancelled here. So this is minus 4, you can shift to that side. This is what? Minus 4. So lambda is equal to minus 2 by 7 now. Lambda is equal to minus 4. Not minus, minus become plus now here. Lambda plus become, right? Oh, you have to multiply by 2 here, right? You have multiplied this, but 12 will be here now. Here will be what? 12 now. Okay. So now, so this is what? Minus 4 plus 6. Minus 4 plus 6 is 2 now, and 2 is shifted there. Then this will be what? 10 now. So lambda is equal to then what? 5 by 7. Lambda is equal to 5 by 7. Okay. Lambda is equal to 5 by 7. You have to find a point only. Okay. You have to find the point on the. You want only the point. We don't want the minimum distance also. Just we have to find a minimum. So therefore x is equal to lambda by 2. Just upon 2 here. So this is what? 5 by 14. Y is equal to what? 1 minus lambda. So 1 minus 5 by 7. So this is 2 by 7. Okay. So now z is equal to what? Value of 3 lambda by 3. So this is what? 15 by 7. 15 by 7 plus 1. So this is what? So 22 upon 7. Right. So your point is what? 2 by 7. 5 by 7. 5 by 7. So this is what? Lambda by 2. So this is 5 by 14 actually. 5 by 14. 5 by 14. 5 by 14. So 5 by 14. Right? So this is a value of lambda is what? Say 5 by 7 and this is lambda by 2. So it is 5 by 14. Y is what? 2 by 7. And Z is what? 22 by 7 is the required point. Is the point on the plane. On the, just we write given plane. Given plane which is closest to A 0 1 1. Okay. So now here what? The problem is over now. Problem is over. Okay. So I think you understand all the thing. Try to solve the number of problems on it. And this is the end of this topic also. And this is the end of the third chapter also. Now from the next lectures we will start the multiple integral. So we will stop here.